receives a medicine of 150 milligrams injection of a drug every 4 hours. And you see what happens. This is a piecewise defined function. As x approaches 4 hours, medicine's concentration in the bloodstream is this low. So 4 hours, after receiving his first dose of medication, after 4 hours, the concentration decreases to this level, let's say 100. Then he gets another dose of medication, and it shuts up to 200, let's say, or more. And then in 4 hours, it decreases to this level. And then 8 hours after he or she admitted to the hospital, then gets a third medication, the third tablet or injection. Now the concentration starts decreasing in the next 4 hours, and then he gets another one. So this is a piecewise defined function. So if I ask you, what is the limit from the left of 8? Of course, you have to figure out what this is. Kind of difficult to read. And the limit from the right of 8, you have to figure out what this is. Again, kind of difficult, like maybe 280 or so. Okay? And if I ask, what is the limit from either side of 8, what will you say?
It doesn't exist.
Thank you. Very good. Okay, so there are problems in which we are given a lot of information. Let's choose a problem like this. And then I would like to look at some limits with different other functions, like natural log, as we discussed, or rational functions, and to wrap up this section tonight. Okay, so first I would like to go back and choose a problem from 15, 16, 17, 18. Sketch the graph of an example of a function f that satisfies all the given conditions. So let's choose one. This is very important. The reason why I'm doing this particular type of problem is for a table that we will be using moving forward. Anyone has any questions, please stop me if you have questions. Anyone? Okay, so are we getting ready to choose?
Can we do 18?
18 it is. So I'm going to copy it, and then I will stop sharing. So we have limit of f of x. X approaches -3 from the left. Limit of f of x as x approaches -3 from the right. And limit of f of x as x approaches 3 from the left. And let me make sure I copied it correctly. Keep an eye on what I copy, because sometimes with this device in front of me, I may not see correctly. Okay, and f of -3, no excuse. Okay, I think I copied everything correctly. Thank you for choosing. Okay, so I come back to this table over and over. Again, this is not the only table. If you prefer a different table, you're free to choose other tables. But this, I don't even need the graph. If you look here. The limit from the left and from the right is 1. So then the limit from either side of 1 is 1. The function value is 3. The limit from the left, -2. The limit from the right, -1. The function value, where the bracket is, -2. It tells me everything at once. Now I'm going to create a table for this information and put everything in the correct order so I can figure out what I need to do. Graph. We're asked to use all this information and sketch a graph that fulfills all the given conditions. Of course, there are millions of different graphs, but we have to make sure that all the information gets in. So first of all, I see -3. Okay, so 0 has to be somewhere in the table, -∞, infinity, so my -3 is here. So the limit as x approaches -3 from the left, from the left with a parenthesis is 3. This is included already. Negative 3 from the right is 2 with a parenthesis. This is included already. So let's see what we established. The limit from the left of negative 3 is 3. The limit from the right of negative 3 is 2. Now, they're giving us limit of f of x as x approaches 3 from the left. So now I'm jumping to 3. 3 from the left is negative 1. So this is already in the table. 3 from the right, okay, fine, is 2. Done. F of negative 3 is 2. That's done. But f of 3 is 0. So, ready to graph. 1, 2, 3, 1, 2, 3. Okay. Negative 3 comma 2. Negative 3 comma 2, this is a full point. And 3 comma 0, this is also a full point. So again, negative 3 comma 2, and this is 3. Okay, these were the full points. The limit from the left is 3. As x approaches negative 3 from the left, the function values approach 3. The limit of the function as x approaches negative 3 from the right is 2. Okay, so the limit of the function as x approaches negative 3 is negative 1. And the limit as x approaches 3 from the right is 2. The reason why this is an open point is because this is full and I cannot have 2 points on that vertical. The reason why this is full because I'm given 3 comma 0. And the reason why these two are open is because on that I cannot have more than 1 point on that vertical. So this is an example, and you can come up with any other example, millions of them, that comply with the given conditions. Any questions on this? This is extremely important to understand how this graph translates into this, how this table translates into the graph. Any questions on this? Anyone? Okay.
So
yes.
I have a question. So when you're graphing this, the shape of the squiggly lines isn't so much important as having the plots.
Exactly. This is not important. You can go this way, you can go this way, you can do whatever.
Okay,
you can do this if you want, as long as it's a function.
I like squiggly lines better.
Anything you want. Anything that complies with the given conditions, the rest is yours. Okay, so moving forward, I would like to so it says determine the infinite limit. So now this is what I would like to discuss for the rest of the 10 minutes we have left. And that will be the end of 2.2. And I don't want to forget 2.1 and 2.2 should be finished as soon as possible. So you can ask questions so we can move on. Okay? Ready? Okay, let's start with 30 and then you choose. So for 30 we have limit as x approaches 5 from the left, x plus 1 over x minus 5. I'm going to stop sharing. Okay, so remember what I said this symbol represents? Oops, I didn't mean negative 1. What did I say it represents? When x, what did I say? X?
The direction it approaches.
Approaches, very good. So x approaches 5 from the left, which means x is not 5. This is automatically. And what I'm going to do now, it will contradict that. And I will say moving forward, every time we are asked to calculate a limit, when x approaches anything, in this case 5 from the left or just 5, doesn't matter for the moment, 5 from the left or from the right, we will plug in. And now you can say, but this is a contradiction. Is it 5 or 5 from the left, from the right, doesn't matter. Is it 5? Do you plug it in? You just say you don't plug it in because it's not equal to 5. True. We will plug it in because we need to know this will give us the type of limit. So only after we plug it in, and we don't have to tell anybody that we plug it in, after we plug it in, we know the type of limit. Before, we don't know what to do. So first, I'm going to plug it in. So when I plug in 5 in the numerator, what do I get?
6.
When I plug in 5 in the denominator, what do I get?
0.
0.
Right. So the answers, so the limit as x approaches a from any function, the answers are, if I have a number divided by 0, I like to say, because students may remember faster, no hope. There is absolutely no hope that the limit exists. And this has 3 possibilities, either infinity or negative infinity or DNE. So if we have a number like this, 6 over 0, there is absolutely no hope for the limit to exist. And there are 3 possibilities, 1, 2, and 3. There is a second alternative, 0 over 0. This one has hope. Notice that I said it has hope. I did not say the limit exists. I said it has potential. It has hope for the limit to exist. This one, never. This one has chances. Not necessarily, but if it's this one, it's guaranteed not to exist. But if it's this one, there is hope. It may exist. Okay, now coming back to our problem. Knowing that it's 5 from the left, and you could say, just write DNE. I cannot, because it's 5 from the left. 5 from the left means 4.9, as we did today with some couple of problems, right? So for x from the left of 4, a close number will be 4.9. Please plug in 4.9 here and tell me the sign. We like to say the sign of this is 0. And there is no sign for 0. But we need the sign here. What is the sign in the denominator?
It's going to be negative?
Yes, because it's 4.9. We're coming from numbers from the left-hand side of 5 with numbers smaller than 5. So this will always be a quantity that is negative. So now positive over negative. What answer do I pick?
Negative.
That's it. That's how I pick that sign. Okay, let's choose another. I'm sharing again. Okay, let's look at 34. On 34, we have limit of natural log of sine x as x approaches 0 from the right. And then at least, please stop me if I don't know what time is it, so that's why, what is my, okay. Oh, okay, I have 5 minutes, good. Okay, so let's do this one and hopefully one more. Okay, I'm asked to determine this limit. Yes, x does not equal 0, but I have to plug it in. I'm not telling anybody You know I'm kidding. I have to plug it in. I don't know what type of limit this is. So first of all, when x approaches 0, this is a function composition. We have to start with the inside, also called inner function, because that's how I evaluate this function. I have to evaluate the inner and then the outer function. So when x approaches 0, right or left, it doesn't matter, but it's 0. Where does sine, the inner function, go? India? Are you there? RJ? Trey? Trey, are you with us?
Sorry, does it come out?
So when x approaches 0 from the right, sine approaches?
0.
Good. And now Nabiha, it's 0 from the right. So now natural log of 0 from the right.
Shouldn't it be 0?
You have to remember the graph of natural log. Do you remember the graph of natural log? Anyone remembers the graph of natural log? 0 from the right.
Negative infinity.
Negative infinity. Very good. Awesome. Please review the graphs. If you have any questions, stop me. Okay. One last one here, 37 or 38. Let's do 38. Doesn't matter. So this is limit of x squared plus 2x over x squared minus 2x plus 1 when x approaches 1. Okay. We plug it in. Can anyone give us the top?
Is it 3?
Yep, the top is 3. I write it on top of the equal symbol. And the denominator is?
0.
Very good. Trouble. So there are 3 possibilities. This, this, and this. The limit will not exist. So now it's 1 from either side. In that case, I have to determine both. But I would like to factor the numerator. Can anyone give us the factored form of the numerator? And in this case, this is a perfect, we just had that question, I think Lindsay asked, okay, what do I do now? When do I know when to determine the limits from the sides, either side, or the limit from either side? Well, here, because it's 3 over 0, I cannot write any of these answers. I have to determine, I'm forced to determine the limit from the left and the limit from the right. Can anyone give us the factored form of the top?
Is it x plus 1, x minus 1?
The top?
Oh, sorry.
The top, yes. So the denominator is x minus 1 squared. Very good. So this is x plus 2, and x minus 1 squared. Good. So now, 1 from the left. 1 from the left is 0.9. The top is positive. I don't need to calculate anything. What about the denominator? What will be the sign of the denominator? Always, actually.
Positive.
Of course. So the same thing here. The top is always positive from the right of 1. The denominator is always positive from the right of 1. They are the same. I will write infinity, which is this, but it still does not exist.